Okay, we will start with chapter 11, lesson 11.1 about space figure and cross section. You already watch a video about this as an introduction. Now, this lesson is easy to understand. We have talked about the polyhedron. That means it's a solid figure. It's the representation of a solid figure. That is in other way, is a 3D figure, three-dimensional figure that has faces, edges that are this line, the representation, is where every side has intersection with the other face. The one face has an intersection with another face, and the corners that we have are the vertex, the vertices of a plural. Now, there is a formula that relates those figures. But first, let's see those things about the vertices, edges, and faces. Here we have a cube. Now, the edges will be every corner that is here. Now, we have every line, the three edges connect and have intersection in this part. Now, the vertex, sorry, this and the edges is this part, every connection of the faces. Now, if we open this, we can see better how many faces we have. In this situation, a cube has 6 faces. 1, 2, 3, 4, and 5, and 6. And again, when they in the intersections, corner are vertex, and those lines are the edges that we have. Now, there are several figures beside the cube, like the cylinder has a net. It doesn't have a vertex. We have one vertex in the cube, in the cone, by the way. In the pyramid, we have it depends on what kind of pyramid we have, but in this has 5 faces here, in four sides, and the base, the quantity of bases of faces. Sorry, the edges are those lines that we will have 4. In total, we have 8. 4 in the base and 4 in every side. And the vertex we will have 5. 1, 2, 3, 4, and 5. The net, we can see it better, shows how many faces we have. We have 5 faces here. Now there is a formula at the beginning that says that relate the quantity of faces with the vertex and the edges. That is the Euler formula. That is this face plus faces plus vertex is equal to the edges plus 2. Now, let's make one example about this. Here we have this polyhedron that we don't have how many faces it has. We know that has 30 edges. That means those lines are 30. And we have 20 vertex. That means every corner we have 20 of those corners. Now let's make the substitution with the formula. Here we are looking for the faces. We don't know what is the value. The vertex is 20 equal to the quantity of edges, that is 30 plus 2, that is part of the formula. Now the next step is isolate the formula. The faces will be 32. 30 plus 2, 32 minus 20. The final answer, the quantity of faces will be 12. That is the answer for that exercise that is there. Now, in the comment of the video, Ada Arguelles and Ronnie Giron has to write the Euler formula, have to only write the Euler formula, and Alejandro Perdomo and Fatima Mende will share with us the quantity of edges of this figure. In other words, have to solve this one. Alejandro Perdomo and Fatima Mende will solve this one, and Ada Arguelles and Ronnie will write in the comments the Euler formula. Now, this part is about the cross section. Imagine that we are having intersection of a plane with a solid that we have, or with the polyhedron here. If we have a figure, for example, in this example that is a triangular prism here, the cross section is a triangle. But if we make a cross section of a cylinder, it depends how we make the intersection will have the figure that is formed. Now, let's see some example of this in action, like this. Example, the cylinder. That was the example that was used here. Now, you can see the plane, we may move it. In the intersection is a circle. You can see it, a circle, and the radius of the circle is constant in this cylinder. Well, if we rotate the plane, now we will have an ellipse that is like an oval. You can see it here. It is also constant, but it's changing. If we have here, it's not ellipse, it's a parabola here. Now, if we continue making a rotation, we will have another figure. If we have vertical completely, the figure that we have the intersection is not a circle. It's another figure. See, the size is not constant. But the name of this figure is you already know, but Emil Defagon and Marcelo Tejada will write the answer. What figure is this? They have to write it in the comment in the video in YouTube. Now let's continue with another figure like this triangular prism. Here we have. Now, again, if the height is in this way, it's a triangle that is constant. If we start making a rotation, we have a triangle in some part, but here is not a triangle. It's a trapezoid. It is a trapezoid, 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 and in this moment, you can see it is another figure. When it's completely vertical, you can see it will be the same answer of the cylinder when it's vertical. Now let's go to another figure. We have cylinders. Let's go with the cone, the cross section of a cone. Now here we have the height. Again, it's a circle, but it's not constant. As a matter of fact, in the top is a point, but here is a circle that is increasing the radius when it's going close to the base. But if we start the rotation of the cross section, here's an oval again. Here is a hyperbola here. Now, in this part, in the top, is a special figure. It is easy to see it here. But Armando Zambrano and Elisa Sarmiento will write the answer. What figure is this, the cross section, in the comment in YouTube. Now, for example, this pyramid that we have, again, how is the cross section is a rectangle here that is changing the size or rectangle. If we make a rotation, it's a trapezoid, and here we go to another figure similar to the cone that we already studied here. But only when it's in the middle and it's completely vertical here, and it is here. See it is the same figure of a cone that is changing. That is the cross section. You have to use your imagination to find what figure are we talking about here in those samples. Now remember, we have several solids. Those are the platonic solid here. You see it? We have several of those. When we move it, we can see the face, the edges, etc. By the way, this is a coordinate plane, and you can see it here. This is the y-axis, this is the x-axis, and the green will be the z-axis because we are talking about figures in 3D. Now, in Google Classrooms for this video, you have to solve the exercise 690 in the page 692. exercise 9, 10, and 11 that is only about finding the missing part faces, edges, or vertices in a figure using the Euler formula for this. Now you can see it in the video because some of your classmates will write it. Remember page 692, 9, 10, and 11. You have to write it, you have to answer in the questions in the Google Classroom. Remember, take a picture of your procedure and upload this part.